Hello students, welcome back to my YouTube channel. This is Kashima Soni and today we are going to discuss in detail the next ionization technique, that is desorption ionization technique, that includes SIMS, FAB and MALDI. So we are going to discuss the third ionization technique, after chemical ionization technique. This is the one that we are going to discuss today. So if you have not seen the previous two videos that I have uploaded in mass spectrometry series, I have mentioned the link in the description box. Go over there, check that first and then switch to this part of the series. Okay, so without wasting any more time, let's switch to that part of the video. Alright, so these are the ionization method that we were discussing. We have already taken up electron ionization and electron impact. We have discussed chemical ionization. Today we will be discussing desorption ionization technique, that include SIMS, FAB and MALDI, not just MALDI that I have mentioned over here. All the three techniques that we are going to take, correct? Alright, so all the three techniques that are involved in your desorption ionization technique, that is SIMS, FAB and MALDI, that I have mentioned in the differentiating manner, so that is easy for you to understand. Okay, so talking about SIMS first, that is secondary ion mass spectrometry. Okay, FAB stands for fast atom bombardment and MALDI stands for matrix assistant laser desorption ionization technique. Okay, so talking about all these three in detail. See, before jumping to that, let's see both of your previous technique that I have uploaded in this particular series, that is electron impact and chemical ionization method. They both require a relatively volatile, or you can say low molecular weight sample. Okay, and now the more recently developed ionization technique allows the analysis of large non-volatile molecules by mass spectrometry, correct? And three of these methods that we are going to discuss over here is SIMS, FAB and MALDI, correct? So what is happening in this particular desorption ionization technique? What is happening? Sample to be analyzed is dissolved or dispersed in a matrix and placed in the path of high energy 1 to 10 kilo electron beam of ions. That is happening in the case of your SIMS. Okay, in SIMS what is happening? The sample जिसे आपने एनालाइज करना है, आप उसे डिसॉल्व करोगे और डिस्पर्स करोगे एक मैट्रिक्स में. We'll be discussing what are the compounds that you are going to use for matrix, that we are going to take up in the next few slides. But for now, just understand what is happening. जो सैंपल को आप एनालाइज करोगे, आप उसे डिसॉल्व करोगे और डिस्पोज करोगे मैट्रिक्स में, and then we will be placing it in the path of your high energy beam of ions. That is happening in case of SIMS. And in case of your FAB, what is happening? The sample to be analyzed and further it is dissolved, dispersed in matrix. You are going to place it in the path of neutral atoms. That is happening in the case of FAB. And when you are going to place your sample in the place of path of highly intense photons, then that is happening in the case of MALDI. Okay, what are you doing? SIMS के केस में आप सैंपल को रख रहे हो in the path of high energy beam of ions. FAB के केस में आप उसे रख रहे हैं in the path of neutral atoms, and in case of MALDI you are keeping it in the path of high intensity photons. Okay. So switching back to SIMS, what is happening? Your what kind of beams are used? The beams of argon plus and cesium plus are used. Okay, and in case of FAB, since you are using neutral atoms, you are going to use the beam of argon and xenon atoms as such only. Okay, and in case of your MALDI, you are going to use nitrogen lasers that emits at around 337 nanometer. They are going to get used in particular method of MALDI. Okay, and in SIMS, what is happening? Molecular ions that are typically formed, it could be M plus H positive or M minus H negative. Okay, and in case of FAB also, these are the molecular ions. The similar molecular ions are going to be formed. And your SIMS can be used for sample compound having molecular weight up to 20,000, such as polypeptide, oligonucleotide. And जो आपके FAB है, it could also be used for such same of your polypeptide and oligonucleotide. While your MALDI, it is quite useful for the analyte spanning a wide range of molecular weight from small polymers to oligosaccharide to oligonucleotide, polypeptide and antibodies. So that is what is happening over here. Okay, and let me switch to the video to the diagram portion first to show you how this process occurs overall. Yeah, this is your schematic representation of DIT, that is desorption ionization technique. So you can see what is happening over here. First of all, your sample molecule to be analyzed or detected, it is dispersed or dissolved in the matrix. Okay, and the dark colored circles are representing your sample, where your hollow circles are representing your matrix molecule. Okay. Now they are placed in your path of incident beam, cesium, for example, in case of SIMS, xenon in case of FAB, and photons in case of MALDI. Okay. Now what is happening after the collision? There is a cascade of molecules. You can see the sample matrix clusters are released now, and what is happening? It results in the formation of either such kind of ions or such kind of ions. Okay, this is the case. So in the detector, using mass by charge ratio, they are going to get detected. Okay, and yeah, that's how it is ultimately going to happen. This particular technique is quite easy to understand, right? So switching back to the previous slide. Alright, so now what we are going to see, we are going to see the matrix. About the matrix, what kind of matrix should be used. So what is happening, the matrix that should be used, it must be non-volatile, relatively inert, and reasonable electrolyte. I repeat, I'll write it for you. The matrix should be non-volatile, relatively inert, and a reasonable electrolyte to allow ion formation. Okay, so these three conditions should be satisfied for a particular matrix to be used. Okay, and if supposing your matrix is more acidic than analyte, then predominantly what kind of ions are going to get formed? That is your M plus H positive. What am I saying? अगर आपके पास जो आपका मैट्रिक्स है वो आपके सैंपल के कंपैरिजन में या फिर एनालाइट की कंपैरिजन में ज्यादा एसिडिक होगा तो आपके पास प्रीडोमिनेटली इस तरह के आयंस बनेंगे. ठीक है, कब? जब मैट्रिक्स कंपाउंड ज्यादा एसिडिक होगा सैंपल के कंपैरिजन में. और अगर आपके पास जब आपका मैट्रिक्स लेस एसिडिक होगा एज कंपेयर टू सैंपल मॉलिक्यूल तो आपके पास इस तरह का कंपाउंड बनेगा -H negative. Okay, negative over there. So such kind of ions could be formed. Correct. So that is one thing to understand. And your matrix absorbs so much of energy imparted by the beam. What is happening? And it will ultimately produce the ions that contribute a large amount of background ions. Understanding? Your matrix itself will be absorbing excess of energy imparted by the beam of ions and produces ions that contribute a large amount of background ions to the mass spectrum. Correct. So that is one more thing to understand. And now let's just see what are the compounds that can be used as a matrix. So talking about MALDI specifically be using matrix are chosen for their ability to be absorbing UV radiation from laser pulse, such as nitrogen laser is being used. That absorbs at 337 nanometer. So compounds that could be used are substituted nicotinic, picolinic, and cinnamic acid derivatives are used. So this one over here is your picolinic acid derivative, and this one is your nicotinic acid derivative. You must draw, if a question like that could be asked, at what kind of compounds could be used as a matrix in your DIT technique. Okay, so you should be drawing these particular structures as well. So you should keep this in your mind as well. Okay, and the matrix absorb much of the energy from laser pulse, thus allowing for the creation of your intact sample ion that are then injected from the matrix. This MALDI mass spectroscopy, as I've already told you, it is quite useful in spanning wide range of molecular weight from small polymers to average molecular weight that we have already discussed. MALDI will be requiring just a few femtomoles of the sample. Okay, so yeah, that's all about it. And what is happening further? The collision of these ions with sample ionize the sample molecule and eject them from the surface. Ejected ions are then accelerated towards the mass analyzer. As with the other ionization methods, same thing is happening in this case also. If the matrix should be non-volatile, that I have already told you, the matrix is more acidic, then it should be M plus H positive ion. And if it is if the matrix is less acidic, then this kind of ion is going to form. Correct. And yeah, these things that I have already mentioned in the previous slide. So you can just write down, make a proper notes of yourself, and you will be able to understand this particular technique very well. So yes, if DIT technique could be asked, you should be drawing this particular diagram also in your subjective paper. So yeah, that's all about this particular technique, that is your DIT technique. In the next slide, we'll be taking the last ionization technique. We'll be discussing that in detail, and that is your electrospray ionization technique. Okay, so yeah. So thank you for watching. Do like, comment, share the link, subscribe the channel, and press the bell icon for latest updates. Thank you.